Hi. So today we are going to do some questions on magnetic field due to a current carrying conductor in different shapes. A straight current carrying conductor, a circular loop, a semicircular loop, or some other forms also. So before starting, let me write the formulas for current magnetic field due to current carrying conductor when it is a straight line, when a straight wire. So, and it is making angle phi 1 and phi 2 at the two ends. The point at which you have to find magnetic field, at point P suppose you have to find field, then formula of B will be equal to mu naught upon 4 pi I upon this distance r into sine phi 1 plus sine phi 2. Now second one, if it is of infinite length for infinite long current carrying wire, B is equal to mu naught upon 4 pi 2I upon R. Now if you have a circular loop, then B will be equal to, and it is carrying current I, then B at any axial point which is at a distance A and its radius is R, then B is equal to mu naught upon 4 pi 2 pi I this R square, this radius square, upon R square plus this distance square, this distance A square whole upon 3 upon 2. So this is magnetic field for circular loop at a distance A from axial point. Now magnetic field at center itself, which is having radius r, at origin O, at center O. So B is equal to mu naught upon 4 pi 2 pi I, if I current is flowing, 2 pi I upon R. So look here, what is difference between infinite long current carrying conductor and a circular loop? Almost same magnetic field is there. Here for circular loop you have to multiply with 2 pi as the angle it is making at center is 2 pi. So here only you had 2I. Pi was missing for long current carrying wire. Mu naught upon 4 pi 2I upon R. And here you have mu naught upon 4 pi 2 pi I upon R, as the angle the circular loop is making at the center is 2 pi. So if you have a semicircular loop, what will be magnetic field? Here the field will be same, but now it is making angle only pi, so it is replaced. 2 pi is replaced by pi. Mu naught upon 4 pi pi I upon R. And suppose it is making only 1/4 of arc. So what will be the magnetic field? What will be the magnetic field? what with at the center, at this point B. This angle is pi by 4. So we keep in mind that angle should be always in radian and angle should not be in degree. So here magnetic field B, due to this circular part of wire, will be equal to mu naught upon 4 pi. I'm doing with magnetic field of only this circular part. Magnetic field of this circular part at center. Okay. So here angle is pi by 4. So simply write pi upon 4 I upon R. So all these formulas are there. Now let me start with question number 1. A 3 centimeter and 4 centimeter arc are two coaxial circular lobes L1 and L2 of radii 3 centimeter and 4 centimeter are placed as shown. What should be the magnitude and direction of current in loop 2? Magnitude and direction of current in loop 2. I is equal to I2. I2 is equal to what? And its direction is equal to what? Okay. So that the net magnetic field at point O is 0. Here you need to have magnetic field 0 at point O, which is at a distance 4 cm from L1 and 3 cm from L2. The two magnetic field is cancelling each other at this point. It means that the two are counterbalancing each other. So if you apply right hand thumb rule for L1 current carrying conductor, the direction of magnetic field is along this direction, along positive x-axis. So you need a current in L2 so that the magnetic field at O should be in negative x-axis. So it will be had only by current in opposite direction, means clockwise direction. So now if you place your curved fingers along the direction of current, suppose this current is I2, then thumb is pointing along this direction. So what is the direction of current? You can have from here only. Direction of current is clockwise direction. Clockwise direction of current. Okay. And for magnitude, let me obtain the two magnetic field and equalize the two magnetic field. Okay. At these points. So we know that magnetic field at an axial point is equal to mu naught upon 4 pi 2 pi I r square, radius square, r square upon r square plus distance, let me take distance x square whole upon 3 by 2. Therefore B1 will be equal to, and this mu naught upon 4 pi comes equal to 10 power minus 7 into 2 into pi, that will be cancelled from both the sides. I, what is I? 1 ampere. 1 ampere into r square. What is r square? So this r square is in centimeter. So let me take the distances in centimeter only. They will be cancelled from both the sides. The unit is not same. Unit is not SI unit, but this distance is going to cancel from the two sides, from B1 and B2. So let me keep it in centimeter only. R is 3 centimeters. So here you have 9 upon 9 plus 16 whole power 3 upon 2. This is B1, and B2 is equal to, again same, 10 to the power minus 7. This value of constant, magnetic constant will be same, into 2 pi I. I2 you have to obtain into r square, and r is 4 centimeters. So 16 divided by, because r square means 4 4 is 16, and here you have 4 square means 16 plus, and this distance now has changed to 3 centimeter. So 9 whole power 3 by 2. So on equating 1 and 2, since both the fields are in different directions and they are cancelling each other, so we will equate B1 and B2, or you can in another way you can say it is I cap. B1 is along I cap and vector B2 is along minus I cap. So on adding the two, it must be equal to 0. On adding, as B at any point, vector at any point is summation of the vectors. B net is equal to B1 plus B2 when they are along a line. Okay, the vectors are added as per the rule of this rule. R is equal to root under. If two vectors are there, A vector and B vector are there, which are at an angle theta, then resultant R is written as root under A square plus B square plus 2AB cos theta. So this is the resultant. But if the vectors are along same direction, which is there in this case, the vectors are in same direction. So when they are in same direction, so simply you will be adding. And when they are along opposite direction, it will have minus I cap and it will be plus I cap. So this is I am going to do. Okay, so simple vector sum is there. As they are along same line, we only add the two vectors. And this should be equal to 0 as per question. Net field is equal to 0. So this is your 10 to the power minus 7 into 2 pi 9 upon 25 whole power 3 by 2 minus 10 to the power minus 7 2 pi I2 16 upon 25 whole power 3 by 2 into I cap is equal to 0, and this implies that 10 to the power minus 7 2 pi 9 upon 25 power 3 by 2. I am not simplifying because it is going to cancel from the two sides. 2 pi I 216 upon 25 whole power 3 by 2. So this is cancelled. This also got cancelled. 2 pi cancelled. Therefore I2 is equal to 9 upon 16. This is in ampere. And I have already written direction is along clockwise direction. Along